So in this video, we're going to talk about trig graphs. And before we can talk about the graphs of these trigonometric functions, we need to recall the unit circle. So the unit circle, if you think back, was a circle centered at 0, 0 with radius of 1. On the unit circle, there were four really important points we talked about. The point 1, 0, the point 0, 1, the point negative 1, 0, and the point 0, negative 1. Those were the important points because if you remember, this was 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and 2 pi. We also know that we can get some angular measure in the negative direction by just traveling around the unit circle in a clockwise manner. So those four red points are going to be important in putting together the graphs of these trig functions. And so you have to remember we are talking trig functions. The unit circle is just allowing us to create these graphs. So for the first one, we'll start looking at y equals sine of x. Now I'm going to go ahead and draw an xy plane. And on the xy plane, you can notice that where the x is right here, that's the angular measure. So along the x-axis, I'm going to have all of the angles. And the angles that I pick are going to be the blue angles that you see over here from the unit circle. So I'll go ahead and I'll start on the positive side with a pi over 2. Then we'll have a pi, a 3 pi over 2, and a 2 pi. And as I mentioned before, in the negative direction, we can get similar angles. So here I'll have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So now, if I look at 0 right here, and again, this is an angular measure, sine of 0, looking back at the unit circle, here's our 0 radians. Sine on the unit circle is the y-coordinate. So the y-coordinate at 0 would be 0. So we've mapped the point now, 0, 0. Moving on now to pi over 2. Sine of pi over 2 puts us up here now. Looking at this point on the unit circle, once again, sine is the y-coordinate. So at pi over 2, we're at 1. So sine of pi over 2 is 1. So if I call this a 1 right here, then my point would be right there. Continuing around the unit circle, sine of pi puts us on this point. The y-coordinate is 0, which means that we have a 0 right there. Continuing now to 3 pi over 2. Sine of 3 pi over 2 on the unit circle puts us all the way over here. On this point, the y-coordinate being negative 1 gives us the ordered pair 3 pi over 2, negative 1. And then finally in the positive direction, sine of 2 pi, coming back all the way around, puts us at 0. All right, so that's the positive direction. The negative direction will be very similar. We've got sine of negative pi over 2. So negative pi over 2 will start us from here and we'll come all the way around. So we'll at negative 1. And then sine of negative pi back to 0. Sine of negative 3 pi over 2 is at 1. And sine of negative 2 pi back to 0. And so if I go ahead and I connect all these dots, this should give us the graph of our sine curve. And there you have it. Now, a couple things to remember here. First of all, the domain. Now, the domain of the picture I'm looking at isn't the complete domain of the graph of sine of x. We chose to go around the circle once in the positive direction, once in the negative direction, and we see that it oscillates as it does. But we could continue this forever and ever, both directions. So the domain of sine is actually negative infinity to positive infinity. You're allowed to plug any value in. Again, that curve can just oscillate forever in both directions. The range is going to be a -1 to 1. And one of the things worth noting at this point is that the range suggests that y has to be between -1 and 1. And we know from what we started with that sine of x is equal to y. So by a simple substitution here, I can say that sine of x is always between -1 and 1. So sine of x is bounded by 1 and -1. The word bounded is going to come up a lot in the course. So sine is bounded between -1 and 1. So something else we'll talk about here is the period. The period is the distance required to complete one full cycle. And so for us, I actually have two cycles on the screen. One of them is pretty easy to see here. If you start at 0, you can see how it goes up, down, and then back up to where we started. So that would be one full cycle. So the distance required to complete that would be from 0 to 2 pi. So the period of sine would be 2 pi. Now, when it comes to graphing these with our transformations, we're going to focus on just one of the cycles, and that's what we'll shift around the xy plane. And as you might already see, it makes probably the most sense to focus on 0 to 2 pi, and that's called the fundamental cycle. So the interval that we're going to focus on, the one special interval that we're going to use every single time for sine would be 0 to 2 pi. All right, so the next graph we'll look at would be y equals cosine of x, and we'll do it pretty much the same way. We still have our unit circle. I'll go ahead and I'll construct the xy plane with the x's once again being the angular measure. We'll go pi over 2, pi, 3 pi over 2, and 2 pi. In the opposite direction, we'd have a negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So again, those are just the angles here that are conveniently on the coordinate axes, which allow us to use the ordered pair from the unit circle. So we'll kind of handle this the same way. If I take cosine of 0, cosine on the unit circle is the x coordinate, so at 0, looks like cosine of 0 is 1. So I have, if that's 1, a point right here. All right, continuing on, cosine of pi over 2. Again, on the unit circle, cosine is the x coordinate, so it looks like we're going to have pi over 2, 0 as the ordered pair. And then for pi, we would have a -1. Whoops. There we go. For pi, we're at a -1. And then for 3 pi over 2, we're back to 0. And for 2 pi, we're up at 1. Going in the other direction now, if I'd look at cosine of negative pi over 2, so now we're coming this direction, looking at the x coordinate puts us at 0. Negative pi would put us at -1, negative 3 pi over 2 back to 0, and negative 2 pi up to 1. Again, just looking at the x coordinates of the red points that we have marked on the unit circle. If I go ahead and connect these dots, there's the graph of cosine. Similar to sine, the domain is everything, negative to positive infinity. Again, we just went around the unit circle twice, once in the positive direction, once in the negative. So officially, the domain is everything. The range is going to be, again, -1 to 1, which similarly suggests that -1 is less than y, equal y is less than 1. So cosine is bounded between -1 and 1. Again, another important thing to remember moving forward. The period, distance required to complete one cycle. You can see, for example, here we would start high, go low, and end up back high. Similar here, I've got 2 cycles actually, so looks like we have a period of 2 pi. And then finally, the fundamental cycle, the part that we're going to focus in on and graph, will also now be 0 to 2 pi.